So hello guys, today we will see how to delete elements from the linked list. I will continue from the previous structure. So however much we have done in the previous video, we will continue from there. Okay, so what we've done, let me see just one second. So there was an add element to index, add element to the first, and there was an comment. Okay, so just let's get started. So we will see three types of things in this today's video. So I'll go through them very quickly. So the first is delete element from last, from first, and lastly from index. Okay. So firstly let's tackle the last part. Okay. So what we're going to do in the last part. So this is going to be a linked list. So let's say every linked list is pointing to its next node, and the last one is pointing to the null. Okay, so now let's see. This is the zeroth number 1, 2, 3. So if I want to delete the last element, which is this 3, so what should I do? So there is already a pointer called tail inside my data structure. So what I'm going to do is, let's say, uh, remember always that the tail should always point to the last node. So the tail, if I say delete the last node, so the tail should point to this second node right now. So what I'm going to do is, firstly, I will iterate, because there is no pointer which is pointing to the backwards rotation. We are only pointing to the frontward rotation. So the point 0th number node will point to the 1st number node, and 1 will always point to the second, then second will always point to the 3, just like this. So there is no pointer which is pointing to backward. So we can't go backwards from temp, right? So what we are actually going to do is, we're going to iterate. Okay, so iterate from where? Iterate from 0 to 2, exactly before the tails element. So now there is a pointer which is here, indexing to 2, just before the last one. So now what I'm going to do is, we're going to say that this second node's next, which is pointing to the third node, will point to null, and this tail will be shifted to this PTR. Okay, so the first step will be what? Will iterate the PTR pointer to before the last node. Before the last node. Okay. After that, what are we going to do is, we'll say that PTR's next node should be null, pointing to null. And the third part will, now the tail should point at PTR. Okay, so done. This is the 3 step we are going to do to implement the last one. Okay, let's just quickly go to our code and okay, so firstly let's just apply those things in here. Void delete element from last. We are going to pass nothing because we are deleting element, and when we are doing this, we should also add delete element from first, and we'll see about the index part. Okay, so not right now, just save this. Hold on a second. Last member cannot be redeclared. Delete from last. So we actually declare delete from last. I'm going to delete this from here. Okay, so now it's done. So we should save this and go to our CPP. Okay, so we'll scroll down to the very last one. Okay, not this one. Okay, so the first thing we're going to do is we're going to specify length list, and the thing we're going to do is delete from last, right? So we'll use delete from last and just scroll down some more. Okay, so the first thing to do here is, what do you say? Just sorry, I think I forgot to shift the window. So just give me a second. Let me switch the window. So what we actually did is, let me just redo it all. So hold on a second. So what we did was we come into this part. So let's just quickly go quit. Okay, so let me just open my Vim. Okay, so first thing we'll go to the header file and we'll add those stuff, right? So the first thing we'll do is go to here and add those things. Delete element from last, and this shouldn't accept anything, any kind of variable, parameter, argument. Delete element from first, and lastly there should be nothing, and this should be our uh, declaration, and we'll define them in here. So firstly I will go to the bottom of the file and start defining them. Linked list, and define the function of delete from last. Okay, then the next part will be like this. So the first thing we are going to do is we are actually going to iterate over to the last node. So let's just do that. Let's Okay, so let me do something here, because we are iterating these things. So let me just copy them. Okay, so we are actually going to copy them. So let's see. Uh, okay. So until this point should be yanked. Okay, so let's go and paste it here. So we'll start from the head part. We'll iterate through all of them. So what I'm going to do is I'm going to destroy this thing and going to add from here. Okay, so where should we go? So we should go before the last element, right? So I is less than total number of 1, because if I want to go before the last element, we should always pass -1, because if you give total number elements, we will always go to the last node, but we don't want to go to the last node, we want to go to before the last node, so -1. Okay, so by this our iterator should now point to before the last node. So after that, what we have done is we will point this uh, iterators next, set next node to null, right? Sorry, null. Let me see. I hope I didn't give anything wrong. Yep, I think I didn't give anything wrong. Let's see what happens after that. Okay, so the next step is done. It's pointing to it's now pointing to the next node address. Okay, so now our tail should point to this. Tail should point to iterator. Now this should actually be it. Let's see. What we're going to do is we are going to say trial dot delete element from the last. Okay, and we should traverse trial dot traverse linked list. Okay, another screen. Okay, so now the next part is delete element from the fast. So let me just switch to my one and see what deleting a node from the fast means. So delete a node from the fast is quite easy. Okay, so I will take 3 nodes. Okay, so what it will do is, say this is the 0 1 2. So we will first create a node. Sorry, not create a node. We will have our pointer in here, head. Okay, so this is pointing to the next pointer node, right? So basically it's very easy. So what we should do is, right now we are not using malloc or heap memories. So in heap case we have to create stuff to get free. You can just, one thing you can just do is, you can just point to the next node pointer of this node. So then the head should point to this one node and this should be deleted. Can do that. But what we are going to do is, uh, we will take a temporary pointer, temp pointer, which will be pointing to head, and now we will shift this head to equals to, sorry, head equals to head, uh, not set, get next node value. Okay, we will shift to the next node value. Done. After that, what we will do is, temp's next value, we'll shift it to null. So that way it's going to remove this link from there. So it's going to shift to null, and now my head should point to this node 1. Okay, so what we're going to do is implement this. So let's go back to this. Okay, so our declaration is done. So let's shift to our file, and after that let's just add it. After that let's just say from fast. Okay, now what we're going to do, first let's take a temporary pointer, temp pointer. So it should point to this head field. Okay, now it's pointing to this cell field. So now the head should update itself. Head and get next node address. Okay, now this should do, and the temp pointer head should, temp pointer heads set function set next node address should point to null. And also let's just make sure we should set the stored data int to 0. That way it doesn't contain anything. Okay, done. So it should work. Okay, so the most of part is done. So let's just quickly go through the next part and just implement some testing phase trial dot. Oh, by the way, I'm just shifting my buffers. So you can see the name of the file in here, main.cpp, and previously I was, so if I go to the previous file, so this was linklist.cpp, and if I go to the previous file, then it was linklist.h, which is the header file, and then I'm shifting this buffer. I don't think I need to split the page to show this thing, so just delete from the first now. So after deleting from the first, we should traverse the linked list. Okay, done. And after this is done, we'll save this and go to the previous buffer. I should save this and go to the previous buffer. I should save this. Okay, done. So what about deleting from an index? So it's just basically the same, as adding to the index. So if you have a linked list like this, so what's it going to do is, so this is 0 1 2 3. So now this is head, this is tail. Oh, one more thing, uh, just switch to this way. We'll first discuss it. So what we are going to do is 0 and 1, right? So first thing we should do is, let's say if I said that delete this second node. So what should we actually do in here? So if I say that, okay, fine, let's do something. We should start an loop from here, iterator point, which will bounce from there to there. Okay, so now we don't want to go to this second node. Where do we want to go? We want to go to this first node. Now what we want to do is, we want to address this pointer in here, so which is addressed here, iterator, which is at index 1. Now this iterator should point to iterator get next node value, next node, iterator get next node should always point to where? This iterator gets next node should always point to this node which we want to delete. So I want to fetch the data, I want to take the data which contains the next node from second node to third node. I want to take the data and set it to this once next node. So by doing this, we'll get a pointer to this second node, right? And now we want to get a value, get next node value from here, get a next node value from here and set it to where? Iterator set next node value to here. Okay, so by doing this, iterator get next node value, we will be getting a pointer. It returns a pointer, node pointer, which will be pointing to this 2, and we will point this whole thing, we will fetch the next node value, which is the value of this edge, this link, and find that value and put it in iterator set next node, which is 1. So this will point to this 3 now, and this whole thing will be removed. Okay, fine. So let's just do it pretty quick. So let me switch with my terminal. Okay, so let's just define this first. Void delete element from index, which should accept an index, and now what I should do is save this and go to my next stuff, and I should increase the space a little bit. Okay, so I will start making that function, defining that function, linked list delete index which will be, the first part is what we're going to loop, right? So what I'm going to do is, I'm going to copy this whole thing. So let's just copy these stuff. Okay, so I'm going to yank that all and then go here and paste it. Okay, so done. So where should we go right now? We should go to the index position. So if someone passes 2, we are starting from 0, right? We are looping from 0, and we should go to 1, not the 2. The index should be put 2 because we want to delete the 2th index node, but we want to go to the index 1, right? So we should go to the index 1. So how we are going to go to the index 1? So if we pass here index value, so I should always point to less than index. So index value is 2. So whenever I reaches to 2, this loop is going to break, right? So by doing this, our iterator should point to the previous node of mentioned index position. Okay. So let's just uh, follow the next step, which was what? Which was actually what I'm going to do is, yeah. So the next step was to delete that variable, right? So what are we going to do? We're going to delete that, right? So first thing we should do is let's just um, iterator. Remember the formula I just write. So just let's check it out. Right? I want to set the iterator next node value, which is one's next node value, to iterator's next node value next value. Right? So it, I know it's pretty much confusing, but let's just draw a quick notation to address this. My iterator is pointing to this node, right? And iterator's next value is pointing to this node, right? And I want to delete this node, delete. And this node, next node, next value is pointing to another node which I want to link with this iterator's node. So what I want to do is I want to set this next value to this specific node. So if we want to set the value, we should set next node, do this, and pass in here what value? Iterator's next value, iterator's next node, get next node value, which is right now pointing to this node. Okay, get next node value, and after that from this node we want to fetch get next node again, so which will be pointing to this node. So I hope it's pretty much clear. So let's just go to the code and do this. Okay, so in here let's just point to set next node value to what? Iterator get next node address, and from here what we want to do is we want to get next node value from also this. Okay, so let me just close my index. Okay, so you can see this clearly right now, right? So we also we can do is this. So we can, for simplicity's purpose, let's just do take another parameter node, and the next node to point equals to should be iterator get next node address, and from here we also want to get next node address, right? So by doing this we can remove all this complexity, and what we can do is we can set this value to next node to point. Okay, so we should be done by doing this. Yep, and now I want to make a change which I have done in add, which is if I want to check if oh, one more thing, let's just do it pretty quick. Whenever I'm deleting some stuff, I want to decrease the value of total number of elements, which is minus, which I going to be negative minus. Let's just go to the next part, and this also I have to do the same thing, total elements and negative negative. Okay, so let's also should return this, and whenever I'm deleting this, let's just first check everything out. If uh, if let's say um, if this total, I want to check if there is any element X which is in existence. Okay, so I really want to check if my total number is element is at least greater than 0, then we can delete, perform a delete, right? Other than we cannot perform a delete. So if this is greater than 0, then we proceed. So let's just make a guard type of thing. So if it is less than equals to 0, this total number of elements, which means there is not a single node which is exist in this linked list. So we should return immediately. Return just it out. No node exists. Okay. So by doing this, return. Yep. And let's do uh, else else stuff, which means is uh, there is some node which actually exists. So let's just dot uh, do that, and let's just copy everything. Put it in here, and let's just take everything and put it one more. Okay. So I should not. So now this is ready, but we also want to put some card classes inside here. So we want to check if the index that the client passes is the pass, is it greater than equals to this total element minus 1, which means this should not do anything, and we should say not let's just not say anything. What it means is, if the index is pointing to a large number of variables, let's say I have 4 nodes but the index is saying 5 nodes. Okay, so in that case, what I want to do is I want to call this delete node from last. If someone passes a large number of variables, I want to delete the node from the last sequence. So, and else if someone does give a node which is specifically telling less than 0, index less than equals to 0, which means someone is passing a negative value, then I want to do a delete from the first. Okay, done. And other than that, in every other cases, this is what we should do is we are going to this out and this is in here, and what we should do is should it like this. That so okay, so this is looking very bad. I know this code looks very bad, but we'll fix it. In our video, we'll fix some errors also, because this function is containing some errors. So for now, the basic stuff, we can do this. So what now let's do is let's do this, and what we should do is we should also update the total number of elements, and we should make a negative negative. So it should be ready now. And now let's just shift to this, and let's just add some also add some variables. So let's just do one thing. Let's just copy some variables from here. Let's just quickly grab some variables from here. Copy this one. Uh, Try this on this. Let's just do one thing. So add it to the last, and then what you should do is trial. Uh, Leave element from index. The index should point to 1, the second element. Okay. So after that, I want to traverse the link. Good. So let's just write it, and let's just run our command gcc main, not main dot, first node dot cpp, and then deletion dot cpp, and then main dot cpp. Okay, so it's compiling quickly, and now we should have an a dot out, which should a dot out. Okay, sorry, I ran the wrong command. Okay, now let's just quickly go through it. Variable what is returning here is this. Let's just copy it and open and just use the let's just paste it in here. Okay, so what I'm going to do is I also going to comment all of this. It is commented. So let's just check it out. So first, when we are creating a linked list, actually what we are actually doing is we are passing. So the first element is 6758, and then we are adding up 45. Then covers the link from there is 32 at the index of 99, 77, covers. We have done up to this point, covers this from line to line. So it should print this, right? This 78 at the first and 99 at the last. So now what it is doing is, so we run a delete element from last, right? So I have run a delete element from last. So the 99 is gone. See, the 99 is gone. Our after the run covers the link. So after that, what I have done is there is what I did is delete element from the last is done, and then we are doing a delete element from the first. So now we have minus 78 at the first. So in the next traverse, in this 19 number of traverse, the minus 78 is gone. Okay, done. Then we also added 758 at the last, right? So what happened in here? Let's see. There is a 99 coming from where? We have to go through this. Delete 99. We will see what happened in the last traverse. But let's just go through it first quickly. The traversing the list. So what we actually did is traversing the list from this part, trial delete element from the index. So 758 is added. So 8 is not added. See, there is some problem about adding stuff, not other than that. So let us quickly go to the add function. No, not this one. Let's just go to the CPP file and add element to the last. So whenever we adding a element, we are doing a plus plus with the total element. That's correct. And now what we are okay. The problem, I found out the problem. So remember the problem I was talking about, that in a video we are going to talk about a problem. So see, we are actually not deleting the node, right? The node is actually there, but we are not actually deleting them. So some stuffs we have done, but in other cases we are not checking if the list is empty or not, and those stuff. So the problem here comes from the adding list. Okay. So after you delete the last stuff from the last list, so this stuff. Okay. So the tail, this tail should point to iterator, which value is set to null. Fine. Up to this is good. After that, when we okay, just let me just open up a window and part. Hold on. Alright, it is. And something wrong. Um, okay, so just go to here and let's open up our main PC here and let's go to the go wrong. So the stuff go wrong when we run a delete element from the first, right? So the first part is good. We're deleting it from there, but after that we're not doing anything. See, after deleting the first, there is a traverse list. So it's gone wrong at there. Okay. So it's printing out pretty good, 45 expected value. After that, whenever we adding a 7 and 5, add element to the last 7, 5, 8, then there is problem happening. We are getting the 99 back, which was after 8. So what happened to delete from last? Let's just go through it once more time. We are iterating to the last node. See, we have iterated to the last node, get next node value. So iterator's next value is set to null right now. Okay, fine. After that, we are setting the tail value to the iterator. So now the tail is pointing to the iterator, and total elements is minus minus. Okay. So we are pointing add element to the last. Okay, good thing. So add element to the last. What we are doing is we are creating a node. We are setting the tail's next node value to the new node. Update the tail to this. Okay, and element plus plus. Okay, that is a good thing. Okay. So delete from last. What happens here is, let's just set next node, iterator next node address to null. We have done that, null. Quarter set null, and this is null. Null. I think we are getting some problem regarding null. So what I should do is I should go for browser and check stuff regarding null. But null is stuff. So I just go directed to the null. So null value plus plus point. So null TDI. Okay. Okay. So the part where the null is stuffed in here is this traversal link from the start, and there is a delete element from the class. Okay, good. We've done until now, And after that, where we're going is delete elements from the last. I've deleted the stuff. Index minus 77. Up till this point, we're okay. And traverse linked list from here, and trial linked list to delete linked list in here from the last. Delete element from the last. Okay. So head to there. Node minus 1. Actually deleting this. The point is deleted. So how's the 99 coming? Yes. Cost 78, and after that we'll done that. 3 parameters I have added. Total elements. Also added them. Minus all of them. First parameter. Detail the first. From point to here. Now maybe pointing to next node address. That is the next node address. Okay. One more thing we are not setting a value. Yeah, right. So what I should also do is null, and before I switch the tail to iterator, let's do something about the this. Okay, fine. Fine. Okay, I didn't save anything in main.cpp. Let's force quit it. I e.out. I'm not getting the last part. What did I do wrong? I copy parameter and go to main.cpp. And from index 1. So our index is working actually. So the 7th parameter is going down. Is coming here. One. Now we have this. We added 753 at the last. Oh, okay. So the delete element from the index is also not working. Okay, so what we should do? Let's just go to our cpp and go to delete element. Okay, it's doing that. Okay, fine. Node pointer is doing this. Okay, that is also fine. Deleting this. Okay. Now here the problem comes. So we are checking the index value is greater than this element minus 1, which is 1 is greater than this element minus 1. No, not true. Because 1 is not greater than equals to index is not less than equals to 0, that is also true. And then here the node iterator says head. I'm pointing to the head, okay fine. I'm traveling to the index. So here the problem is I pass 1. So 0 is traveling to what? 0 is traveling to all of these, right? So is I should be less than 0. Not true because I is also 0 and index is now becoming 0 because I am passing index 1. Okay, that is bad actually. Okay, okay, I have to debug this all of this. Okay, node address. So say pointer. Okay, there's no problem regarding this. Let's just quickly solve the issue. So what I'm going to do is index value minus 1, which is inserted from the ith list, getting the next I value I is less than or equal to 1. Pointing to head, right? Head. I'm pointing to head. Now I want to delete the index 1 iterator, right? So if I want to delete the 1 iterator, it's not going to run any time. So because 0 is less than 0, false, not going to run. Iterator is pointing to head. So now my new pointer would point to the second index of the variable, and which is going to set to the head. So yeah, this is by doing the solution for the index part will be solved because that was the problem. And from the last part, out. Okay, now this is deleting from the stick. Okay, so one problem is solved, but the issue still consists of 99. Fix the variable of 99. This is somehow coming 99. I don't know how. Are we not updating the tail? Check that. Not updating the tail. Delete from the last. Actually, we are index to add. So this is so last. When we are adding last, adding a value, we are taking the tail value and setting it to the next node address, just to the new node. Okay, and set the tail to new node. Okay, fine, not a problem here. Okay, so the last node is good. After that there is 99 problem. So we're passing a big value. When we're passing a big value, it should by default go to this, that is going to the last. This is true, it's on to that. Okay, done. And after doing that, we're also increasing value. Good. So now when we're executing delete from the last, I'm taking a iterator to the head. Okay, good thing. So I am just okay. Now this is problematic. So see one thing. See, I am now going to this total elements minus one parameter. Okay, so actually where this total element minus one point. Total element is representing if my linked list has four nodes. So the total element value should be 4, right? And now the problem comes is when let's say the total element is 4. If I so the, what should be our indexing, right? What should be our index? So we are starting from 0. So the tail is at third index, right? So we are actually traversing from this total index. So total number is 0. Is set to total number is set to 0. Okay, so we are implementing total number to 1. Okay, no, that is not a problem. So delete element from the last. We are traversing total element. So this is 1. Actually, okay. Whatever the total element is, minus 1. So if the total element is 4, then it should become 3. And I should always take the previous value of 3. So 3 is pointing to cell, and I am going to the next parameter. If I am at 0th index, so I will go to the next node minus 1. Okay, so the problem consists in here. I shouldn't go to this, I should go to this. And why is that? If you see, we are using the total element concept, right? So uh, if I pass, let's see, our 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 linked list have two elements, so 0 and 1. Two elements, 0 and 1. So total element number is 2. And now I am setting I equals to 0. Okay, fine, that is good. I should be traversed under this, what we have previously is this. It means this class total element, which is minus of 1, which I have previously. Minus of 1, 2 minus of 1, 1. 1. I should traverse until my I is less than 1, which means 0. I can only get to traverse 0 times. So after I get to this part, which is iterator, which is pointing to the head node, and I am already updating the iterator to the next node, right? See, I'm already updating the iterator to the next node, which means if I go to this, let's say go to this. So if you see the iterator, the is value, I value is initialized to 0, and I is less than element total element minus 1. This was our criteria, right? And inside this I was updating the iterator to iterator next value next value. So see, if our head is iterator is set to head first, so there are two elements, 0 and 1. So iterator is pointing to this, iterator is pointing to the 0th element, and now I am running this I, so the I value is 0. So my requirement is I should stop before the last tail element, before the tail element. So what is our tail element? Tail element is 1, so I should stop at head. But if I run this formula, see, this is going to execute one time, and because this is executing one time, the iterator is by default is updating to 1. So that is where we are doing wrong. So we should update this whole thing so that it not do that wrong. So I'm going to pass this value. I don't know why I did this. Parenthesis doesn't need, you don't need parenthesis. Just should now work good and well. So also here we are indexing from this. So yes, now we go to this and quit now and run our program. This should solve the problem. I hope that this solves our problem. Yep, this solve the problem. See, 45, 7, 82, 5, 8, 7 and 99 is gone. So last we added 7, 5, 8 and we deleted the one index parameter. Remember? So the 6 is deleted. So this was it for the linked list deletion, but I know the video is gone too long because I made a mistake. I'm really sorry about that. But as I said, this is a very casual thing. I'm going to make mistakes and fix this. So if you from after this video, if you see any kind of mistakes I'm happening, so just scroll through the video by clicking 10 seconds and going to the 10 second in future, 10 second in future and those, and you will find a point where I fix that video. So fix that problem and just stumble upon that solution and just understand the solution and go on. Thanks for watching, and I should now quit this video, and thank you again. And one more thing I just want to inform is that from the next structure, I'm going to implement a circular linked list. So I was hoping I'm going to make adding, traversing, all those stuff uh, in one video and post it in the weekend. So I'm going to record the video per day. So in that case, I just want to inform you that. And after this video, tomorrow I will upload another video where that's going to be a short video if I don't make any kind of mistake, and that video is going to be about make files, so that we can just use that make file to compile very fast and run the program at the same time. Okay, so see you in the next video. Thank you for watching. Bye bye.